Uh, Hello friends. Today's topic is ECDIS settings. Okay. So in ECDIS, mainly five settings are there. Not five. There are. I will explain all the settings. First, we will tell about the five settings. Okay. So these five settings are mainly uh, safety depth, okay, safety contour, safety contour, shallow contour, okay, deep contour, and the fifth one is safety height. Okay, so there are I consider there are two more things. Look ahead function. Look ahead function. Okay, so this function doesn't require much of any calculation. It is user defined, or whatever your QHSC manual says. According to that, for different areas, you can select this lookahead function. No calculation is required. You can directly put this function. But these five settings, you cannot just put any random number. You need to apply some basic calculations and you will get some values. Okay, so that value only you can put it inside ECDIS for each of this value. Okay, so we will go to uh, first these three values. Okay, okay, now what is safety depth? Okay, safety depth. To get the value of safety depth in ECDIS, uh, there are simple steps. First, you need to have dynamic draft. Dynamic draft. Okay, and then you have to add company UKC policy. Okay, UKC policy. Okay, so in UKC policy, you, as per your UKC policy, whatever is that value, that has to be applied. Okay, my company UKC policy is 10 percentage of um, static draft, maximum static draft. Okay, or 1 meter. Okay, and among this either 10 meter or 10 percentage of the static draft or 1 meter. So among these two, whichever value become greater, then that value must be selected. For example, my draft is 12 meters, so 10 percentage will be 1.2 meters. So instead of 1 meter, I have to select 1.2 meter. Okay, that is the idea, whichever is greater. And another part of the safety depth calculation is UKC policy, I already told, and depth accuracy. Depth accuracy. Depth accuracy. So depth accuracy is defined by CATSOG values. Okay. Okay. CATSOG rating. So as per the CATSOG rating, there are if you go to ENC and look for the CATSOG values, there are values like A1, A2, B, C, D, U. These are the six CATSOG value you will find on the charts. So this A1 and A2 is considerably best values. Okay, so that means the accuracy is the error in accuracy is less. So best more accurate value, and so the error is less, and the D is considered as the worst. Okay, and the U means unassessed. Okay, I will make a separate video for this CATSOG value, how much is the percentage of error and everything. I will make a separate video. Okay, and apart from this depth accuracy, there is one more thing we have to apply with the safety depth calculation. Okay, I will write that also. Okay. So one of this dynamic draft, we will add UKC policy to the safety depth, then add depth accuracy, then we will minus height of tide. Okay, if the port in which we are arriving there is no tide, then no problem. So wherever applicable. Okay, in a port where height of tide is 0, then automatically nothing. If you put 0 here, there will be no change. Okay, so this is the quick formula for you to calculate the safety depth value. So what is safety depth? That is dynamic draft plus UKC plus depth accuracy minus height of tide. So you will get safety depth. Okay, now next one is safety contour. So safety contour value, safety contour is same as safety depth. Okay, that's all. Now the another part of the setting is shallow contour. Okay, now the shallow contour value is vessels. For shallow contour value, let's write it in another page. Okay, another one is shallow contour. Shallow contour. So for shallow contour, the obviously the vessel dynamic draft. Okay, if the vessel is not even keel, then if the vessel has a trim, then we should use maximum dynamic draft. Maximum dynamic draft should be used. Okay, and minus that dynamic draft minus height of tide. Okay, this is the formula for vessels shallow contour. So let's say your dynamic draft is 12 meters and you have a tide of 2 meters and your shallow contour will be 10 meters. Okay, this is the formula. Now the second, this is the third one. Okay. Now the fourth one is deep contour. Okay. So deep contour we can get is the it is a some no, static draft. Okay, static and dynamic draft. Okay, the sum of static draft and dynamic draft is called deep contour. Now some of you may have a confusion between what is a static draft, what is a dynamic draft. I will explain what is dynamic draft in few minutes. Okay, let me finish the fifth point of the safety setting. Okay, safety set. Next one is safety height. Safety safety height. Okay, safety height of the vessel can be found out airdraft plus height of tide. Okay, now every company has a UKC policy. Similarly, there must be an air draft policy. Okay, so that air draft policy must be okay. So this air draft policy for my company is 2 meters. Okay, so this is how we find out the safety height. Okay, so different company may have different value for this draft, so you put that value here. Okay, now I would like to explain little bit about dynamic draft and static draft. Otherwise you will get confused. Okay, when a vessel is floating freely on water, okay, when a vessel is floating still on water, the water is not moving and the vessel is also not moving. Okay, at that condition the draft means distance from the keel of the vessel to the water line, that is called draft. So that at the draft is called static draft. Because there is no effect of any vessel movement or water movement affected in this static draft. Okay, now another thing is dynamic draft. In dynamic draft, what is happening? Okay, when the ships moves through water, there are a lot of factors are affecting in the ship's structure. So in draft, okay, so there are factors like squat, okay, and rolling and pitching, okay, rolling and pitching, and other factors like rolling, pitching, reducing, and heave. Okay, so when the ships moves through water, these factors will apply to the ship's draft. So these and in open waters, okay, in open water, this uh, effects is negligible. Okay, but as compared to the shallow water. Okay, so most of the time grounding and everything happens in shallow water only. So uh, during if you proceed to shallow water uh, without considering all these facts, the calculation of the draft and everything will become wrong, and we end up in grounding. Okay, so to avoid that, we apply all these factors along with the static draft. Okay, so the value of static draft plus all these factors will give a new value, that is called a dynamic draft. Okay, so this is how dynamic draft is derived. So when I said about a deep contour value, the actual static draft value plus the dynamic draft value, that is how we will calculate the deep contour value. Okay, and when I said about the shallow contour value, the dynamic draft value, which contains the contains the effect of Scott, roll, pitch. Okay, everything will be added. That value will be used here. Okay, similarly, in the safety depth, the dynamic drafts means all the value of the roll, pitch, Scott, heave, everything will be added. Okay, that value is used for the safety depth calculation. Okay, then normal UKC policy and everything will be used. Okay, so I will be making another video about this cat sock. I believe this video is almost 17 minutes. Okay, I will explain other in next video. So thank you friends. Bye.